Hi everyone, I am Priya Jose, Assistant Professor, Department of Basic Science and Humanities, Jyoti Engineering College, Cherudurti. Today, I will present the helium neon laser, its construction, working, advantages, disadvantages, and applications. Helium neon laser, it is the first gas laser fabricated by Ali Jamal in 1961. It is a 4-level laser. 4-level means there are 4 energy levels. First one, ground state. Second, excited state. Third, higher energy level. And fourth, lower energy level. The 3 energy transitions are taking place between 4 energy levels. Construction. For every laser, there are 3 parts. First part, active medium. Here, the active medium consists of a mixture of helium and neon gases, which is taken in a glass discharge tube in the ratio 10:1. The ends of the discharge tube, this end and this end, are tilted at Brewster's angle and are sealed by inclined windows known as Brewster windows. These windows are highly transparent to the preferred direction of polarization. So the output from this laser is plain polarized light. Next is pumping mechanism. Here electrical pumping method is used. So the electrodes are provided here to provide the electric discharge in the gas, and these electrodes are connected to a high power supply. Then they produce electrons and excite the ground state atoms to the higher energy states and by achieving population inversion. Third component, resonating cavity. It consists of 2 mirrors, M1 and M2. Here the mirror M1 is fully silver, so it acts as a 100% reflecting mirror. The second mirror M2 is partially silver, so it's partially reflecting and partially transmitting. Then the photons produced during stimulated emission are shuttling between these 2 mirrors a large number of times, and during each transition it stimulates more and more atoms and thereby producing more and more photons, and finally the powerful laser light emerges out through the partially reflecting mirror. This is the construction of helium neon laser. Next, working of helium neon laser. Working of a laser means how the 3 energy transitions are taking place. This figure shows the possible energy levels of helium and neon atoms. In figure, F1 is the ground state of helium, F2 and F3 are the 2 excited states of helium. On the right side, E1 ground state, E2 next to higher level. Here E4 and E6 are the 2 metastable states of neon, where the population inversion is achieved. And E5 and E3 are the 2 lower laser levels. The first transition, here the pumping mechanism is electron pumping. So the electrons from the discharge tube collide with the ground state helium atoms and excite them to the higher energy states F2 and F3. This is the first transition, that is stimulated absorption. Schematical representation of this transition is ground state helium collide with a high energy electron, and after transition He star means helium atoms are in the excited states F2 and F3 plus the electron. Then next transition, in this figure the energy level F2 of helium and the energy level E4 of neon are in the same level. Also, the energy level F3 of helium and the energy level E6 of neon are also in the same level. So, the helium and neon atoms interact, and through the atomic collisions between helium and neon atoms, there is an energy exchange. That is, helium atoms are de-excited and neon atoms are excited to the levels E4 and E6. That is, before transition, helium atoms are in the level F2 and F3, and these high energy helium He star make atomic collisions with the lower energy neon atoms and they exchange their energy. So neon atoms are excited to the levels E4 and E6. Now neon atoms are in the level E4 and E6. These E4 and E6 act as metastable state and population inversion is achieved in these states. Then stimulated emission takes place from E6 to E5, which emits a laser light of wavelength 3.39 micrometer, which is in infrared region. Next, stimulated emission from E6 to E3, which emits a laser light of wavelength 0.6328 micrometer, which is red in color. This is the prominent line of this laser. The third stimulated emission takes place from E4 to E3, which emits a laser light of wavelength 1.15 micrometer, which is also in infrared region. That is, here three types of laser beam are emitted. Then these photons produced during stimulated emission are enhanced by the shuttling process of the photons between the mirrors M1 and M2. Finally, the laser beam is emerging through the partially polished mirror. Then now the neon atoms are in E5 and E3. From these states, they make spontaneous emission to the level E2. Then at the level E2, the neon atoms collide with the walls of the discharge tube and they are de-excited to the level E1 and that cycle is completed. This is the working of helium neon laser. Next, advantages. The output of laser is a continuous beam and it's highly monochromatic, that means single color or single wavelength, and it has high directionality, easy to construct and operate. There is no need of cooling mechanism as in ruby laser. Then there are different frequencies are emitted. We can select the proper frequencies by using suitable filters. Disadvantages. The efficiency is low and the output is moderate when compared to ruby laser. Then let us conclude this presentation with the applications of helium neon laser. This laser is used to read the data that is enclosed in CD, DVD and laser disc. Used for laser printing, laser fan machines and laser pointers. Used in fiber optic communication as light source. Used in measurement process. Used in barcode reading and scanners. Thank you.